Hello, and welcome to the first of several videos that I'm recording. I hope you're enjoying your morning, afternoon, evening, or night, whatever the case may be. And I just wanted you to know that this is the first one so you could have some insight into my life. I'm going to be recording a bunch of videos today, but this is the very first one. And it's just some material that I had hoped to get to at the end of the scanf lecture in week 2 and just didn't have time to get to. It's not really required for the subject, so you can skip this video if you're really goal-oriented. But I think it's interesting, and especially if you're going to go on and do some programming in the rest of your life, it's material that I think you would want to be aware of. So, up until now, up until scanf, all our programs have behaved the same way every time. They might not work the way we wanted. They might have warnings or errors or incorrect calculations or any number of things. But if they're wrong, they're predictably wrong. Now that we're dealing with user input, that's no longer the case. So users aren't necessarily going to follow your expectations, either on purpose or by accident. Even if you are the only person using your program, you might mistype something, you might fat finger it, you might forget what order your scanf conversion specifications were in. So in this subject, you get to assume that the input you get is well behaved. So we say that when you expect an integer, you get an integer. You don't have to error check. But in the real world, you're not going to be so lucky. So this is just a quick scanf program that I've written to demonstrate some of the functionality of scanf. And here we have just two integer variables, int value and num, one floating point value, float value. Then we have num equals scanf %d%f reads in an int into int value, a float into float value, and then we print out with printf the value of num, the value of int value, and the value of float value. So num here is a value that is returned by scanf. So scanf up until this point, and even in the future, we don't necessarily use a return value. We just do scanf on a line by itself. And by doing that, we're throwing away the return value that scanf has. But it's actually useful, so I think that what you should do is rather than throw it away, record it in a variable. Then you have access to it if you need it. The return value of scanf is an integer that is the number of input items that have been successfully matched and assigned. Okay? So you can use this to test if your scanf is behaving the way you expect it to. So here, we've compiled the program, no errors, no warnings. We run the program. I type in 1234 space 5.6789, and then it prints out num equals 2, int value equals 1234, float value equals 5.6789. So 1234 is an int. It is correctly read into int value. 5.6789 is a float. It is correctly read into float value. And num equals 2 because we read 2 values. So at the very least, we know that both int value and float value have reasonable data in them. You know, they may be negative numbers. Your program may not be equipped to handle that. You have to worry about that separately. But we know that int value got something and float value got something, right? But now we build again, we run again. I type in, instead of an int and a float, I type in ABCXYZ. So num equals 0, int value equals 221,552,694, and float value equals 0.0. So what happened was we see A, we try to put it into an int. The conversion specification says, hey, wait a minute, A is not part of an integer. I'm not even going to try to assign anything to int value. And then float value it never even gets to. So we have num equals 0 because neither of these values were successfully read by scanf. So you have to be very careful because num is not what you expect. If num were 2, the rest of the program could proceed as if nothing terrible had happened. But because it's 0, maybe you want to quit the program and print out a warning message because you know that these datas are probably garbage. Okay? That leads me to another point about scanf, and now that's on buffer overflow. So essentially a buffer overflow occurs when you attempt to write more data into a variable than it is capable of holding. So you've got this much variable and this much data, right? You can't fit this into this. So it's going to spill out over the end of the variable and write into adjacent locations in memory. This is really, really bad. So at the very best, you're going to get strange, unexpected behavior, but your program might crash, or you might even give someone a security vulnerability into your system. And sloppy use of scanf is a common source of buffer overflows, okay? So here's just a really simple program that I've written. It does make use of an array, which we haven't talked about. That'll be the first lecture next week. But all you really need to know is that we have a variable named input that holds 8 cars, okay? It's 8 cars long. So we read a string into input, and then we print out input using printf, okay? And on my computer, I type in testing, and I get back testing. Everything works just fine. I type in a bunch of random garbage from my keyboard, and I get this abort trap 6, which is my computer looking out for me. My operating system is saying a program tried to access memory that it wasn't allowed to access, so I have prevented them from doing any damage with that, right? And that's because this is too many characters to fit in here, which only holds 8, right? So that's my Mac. We can also run this on latcs5, and once again, testing works fine. And once again, when I mash the keyboard, I get problems. In this case, I get a crash and a segmentation fault, which is the same thing. It's data was trying to be written into memory that the program doesn't have access to. Okay? Fortunately, all we have to do is use the optional width parameter in scanf, and this will never be a problem. Right? As long as you set your read to be less than or equal to the size of your variable, you won't have buffer overflows. So I recommend always doing this, even though we're not necessarily checking for it in the assignments. It's just a good idea. It'll prevent you from accidentally crashing your program, right? So here, the only difference in this program is this %8s. I have added the width parameter to my scanf, and it's the same as the size of my car array. So testing still works fine, and now it works fine even when I mash the keyboard. It's just that it only prints the first 8 characters. So because I've used %8, only the first 8 characters get stored into memory. And we can try this again on latcs5. Testing works fine. A bunch of garbage also works fine because the array is of size 8. I've read 8 characters into it. Only the first 8 characters get stored into memory. So this is just a really good habit of getting into. I recommend that you do it all the time, even though it's a little bit beyond the scope of this subject. I think it's a good idea. Okay? That's all I have for you in this lecture. This is a quick one. Several of the other ones are going to be longer. But stay tuned. There will be a bunch more. I hope you find them useful and educational. I'll see you soon and be well.